Let's talk about algebraic proofs, which is really just another way of saying, let's talk about solving equations. But the difference between what you've done in the past in Algebra 1 in 8th grade and what we're doing today in geometry is that we're going to solve equations, but we're also going to justify each step with a property of equality. So before we get into the new stuff, let's just make sure we know the old stuff first. Let's solve this equation. It's a pretty big one. We've got a whole lot going on. The first thing I see, though, is that I have parentheses, so that's what I'm going to take care of first with something called the distributive property. And that tells me that I can multiply 9 by 4x and 9 by negative 5. 9 times 4x is 36x, and 9 times negative 5 is minus 45. And then the rest, I just copy down exactly what I saw because I didn't change anything about that part of the equation yet. Okay, now on the left side of the equation, on the left side of the equal sign, I see some like terms. I see a 36x and a minus 2x. These are like terms because they both have an x, and that means that I can combine them. And since they're on the same side of the equal sign, I'm going to use the same sign that I see. I see a minus, so I'm going to use a minus. 36 minus 2 is 34. So I have 34x minus 45 equals 18x plus 3. Now my goal is to get x's together on one side, and constants, which is another word for the number that doesn't have a letter with it, together on the other side. So I'm going to start by subtracting 18x from both sides, and that gives me 16x. Then I'm going to add 45 to both sides, and that gives me 48. So now that I have x's all together on one side and constants all together on the other, I can divide both sides by the number in front of x to get to my answer of x equals 3. So basically what we're going to learn how to do in this lesson is say why we're able to do each of these things. And when you do that, when you say, I did this and the reason I could do it is because of this thing, that's called a proof. In order to solve an algebraic equation, we use properties of equality. Those properties allow us to manipulate the equation in order to isolate the variable, which is a fancy way of saying add or subtract or multiply or divide until we get the x alone. Being able to solve algebraic equations using the properties of equality are going to allow us to solve more complicated problems later on in this unit and for the rest of the year, problems that involve the segment addition postulate or angle addition postulate or any number of things. So let's go ahead and learn the properties of equality. First we have the addition property of equality. It says that if A equals B, then A plus C equals B plus C. Well, what does that mean? Basically, it's just saying that if you have an equation, so A can be whatever and B can be whatever, it's not just a single thing. It's basically like this whole side is A and this whole side is B. I have that kind of equation. Then I could add the same number to both sides of that equation and it's still a true equation. It remains balanced. Now, typically we don't have to deal with equations as complicated as our warm-up. Sometimes you have equations as simple as this one. X minus 1 equals 4. Well, since that's a minus, if I want to get rid of minus 1, I can add 1 to it. Now, typically we write our work like this, underneath of the numbers, that we're adding 1, which is C in this case, to both sides. But technically, and I'm sure you've probably never seen it this way just because it takes extra space, no one writes it like this, but the technical way to write it is all in one line, like this, that x minus 1 plus 1 equals 4 plus 1. So I'm adding that C value of 1 to both sides, causing the minus 1 and the plus 1 to cancel. So I would get that answer of 5, because 4 plus 1 is 5. We also have the subtraction property of equality, which says basically the exact same thing as the addition property of equality, except we're subtracting C instead of adding C. So if you have some kind of an equation, A equals B, then you can subtract that number, whatever that number is that you need to. In this case, it'll be a 2. You can subtract it from both sides. Now again, we typically write our work like that, but according to the property, it should be all in one line. It really doesn't matter to me how you write your work if it's like this or like that. It's all saying the same thing, and you'll get to the same answer of x equals 6. We also have the multiplication property of equality, which says that we can multiply both sides of that A equals B equation by some number C. We don't use the multiplication property of equality very often. Basically, we only use it with fractions, because to get rid of a fraction, you can multiply by its reciprocal. So the reciprocal of 1 over 3 is 3 over 1. So I'm going to multiply both sides by 3. That gets the 1/3 and the 3 to cancel out, so my answer would be 12. And if we have addition, subtraction, and multiplication, you know that also means that we're going to have division. If you have a equals b, then you can divide both sides by c, and it remains balanced. So if you have 6x equals 42, again, we typically write our work like this. Technically speaking, it should be written like this. I really don't care which one you write it as, because you're going to get to the same answer of x equals 7. And we also have a couple other properties that aren't properties of equality, they're just properties that we tend to use while solving equations. And the first one is called the distributive property. It says that if you have a times some quantity b plus c, where b plus c is in parentheses, that's equivalent to a times b plus a times c. Which I think we're all pretty good at the distributive property, so I don't think we need too much more of an explanation of that, but let's just go ahead and look at an example to be sure. Since I have 4, that's a, and then 7x plus 5 in parentheses, that's my b plus c, I could say that that's actually the same thing as a times b plus a times c. So that would be 4 times 7x, a times b, plus 4 times 5, that's a times c. And then you can just simplify that. That's 28x plus 20 equals 76, and then solve the rest of the way from there. And again, we'll see exactly how in a second of how you can combine all of the properties of equality. Then next we would use the subtraction property of equality, and then we would use the division property of equality to arrive at our answer. And then the last, not really property, just thing that we do to equations, is combining like terms. It doesn't really get its own property, we just call it combining like terms. And we use this if there are 2 or more like terms on the same side of the equal sign, then we can combine those terms into one term. For example, if I have 3x plus 7 plus 8x equals 29, well, the 8x and the 3x are like terms because they both have x, and they're on the same side of the equal sign. They're both on the left-hand side, so that means I can just combine them into one term. 3x plus 8x is 11x. And then again from there, you would have to combine all the other properties of equality to get to your final answer. We'll do that here in a second. But first, let's talk about how do we write a proof. Every time I ask you to write a proof, I'm going to give you 2 things. I'm going to give you a statement called the given, and I'm going to be giving you a statement called the prove. The given statement is what I'm telling you has to be true. In this case, for algebraic proofs, I'm going to give you an unsolved equation. And then I'll also give you a prove statement, and that's basically the goal. That's the answer that you're trying to get to. So for our problems today, since they're algebraic proofs, it's going to be something like prove that x equals 7, or prove that x equals -2. And our goal is to get from the given to the prove. And we're going to do that with 2 columns of information. The left column is for your statements. Those are the things that you know are true. And for our proofs today, since they're algebraic or equation proofs, it's just going to be you showing the work of solving the equation. It's going to be what you already know how to do from 8th grade in Algebra 1. What's new for today is the right column, which is your reasons. And that's all the things that we just talked about. Those are all of your properties of equality, or the distributive property, or combining like terms. Now, as we get to more complicated proofs later in this unit and throughout the whole rest of this class, we're going to have other things that we get to use called theorems and postulates. We'll get to those later. For now, you're just going to be concentrating on the properties of equality that we learned earlier in the lesson. So let's give our first proof a try. This is the basic setup that you'll see for every proof that I give you this year. I give you a given statement, I give you a prove statement, and I give you 2 columns to fill in. The left column is for your statements. Those are the things that you know are true. For this kind of a proof, it's just going to be the steps of solving the equation. And then the reasons column are for all of the properties of equality that allow you to do each step in your proof. The first line of a proof is always the easiest, because it's basically just copy and paste. So the first statement is always your given statement. So you just get to copy and paste exactly what you were given into the proof. And your reason is because it was given. Reason number one on literally every proof I'm going to give you ever is given. So no matter how hard you think proofs are going to get, you at least are able to do this first step successfully every time because it's copy and paste and it's the word given. Couldn't be easier. But now we have to solve this equation, and our goal is to get to an answer of x equals 8. Well, let's see if we can do that. If I want to solve this equation for x, I would need to get rid of 5. 5 is being added. The opposite of addition is subtraction, so I would subtract 5 from both sides. And that gives me the answer of x equals 8 that I was asked to prove. And my reason, the reason I was able to do this whole subtract 5 from both sides thing, is the subtraction property of equality. Feel free to abbreviate. You'll see me abbreviate like all the time in this class. I almost never write out a full word, but I am a little bit picky about the abbreviation for subtraction because 2 lessons from now, I'm going to teach you the substitution property of equality, and both subtraction and substitution start with SUB. So it's important to me that you don't just write SUB for your abbreviation on subtraction. Go ahead and write SUBT so that I can differentiate between the subtraction property of equality and the substitution property of equality. Other than that, abbreviating should be pretty easy. Let's try another one. Our given is 9x equals negative 45, so I can copy that down as my first statement, and my first reason, of course, is given. My prove statement is x equals negative 5, so I need to somehow prove that 9x equals negative 45 is equivalent to x equals negative 5. Well, let's see what we can do. In order to solve this equation, I need to get the 9 away from the x. And since the 9 and the x are being multiplied, I can divide to get rid of it. So if I divide both sides by 9, I get an answer of x equals negative 5. Perfect. That's what I was asked to prove. Well, what's my reason this time? What did I do to get from my given to my prove? I divided. So my answer for the reason is the division property of equality. Okay, those first two were pretty easy because they were just 2 steps, the given and the prove. But more often than not, you're going to have more than just 2 steps to deal with, so let's take a look. First thing I'm going to do is just copy and paste my given. My given was 2x minus 17 equals negative 9, and the reason is that it was given. And I'm going to try to prove that x equals 4. Well, let's just solve the equation and see if we end up with that prove statement. The first thing that you're going to want to do is either add or subtract, and then you'll finish up with multiplication or division. So for this example, since I'm subtracting 17, I need to add 17 to both sides to get those 17s to cancel out. So I still have 2x, and then negative 9 plus 17 gives me positive 8. So what's my reason? Why was I able to add 17 to both sides? Well, that's the addition property of equality. Now we have another step, right? Because we're not quite to our proof statement yet. I'm trying to prove that x equals 4, and right now I have that 2x equals 8. So the last thing I need to do is divide both sides by 2, so that I can get x totally alone, and yeah, x equals 4. Looks like I proved it correctly. But I still have to give my reason for why I was able to get from 2x equals 8 to x equals 4, and that answer would be the division property of equality. Our next proof has a fraction, but no need to freak out, I promise it'll be fine. Copy down your given, write the word given. The first step is always the easiest. And from here we just need to solve. Our first step thankfully doesn't involve the fraction at all. My first step is just to subtract 5 from both sides. So I get 1/6 x equals 3. The reason I was able to do that? Well, I subtracted 5 from both sides, so that must be the subtraction property of equality. Again, remember that t, it's not just SUB if you're abbreviating, it's SUBT, so that we can distinguish between the subtraction and the substitution properties of equality. Okay, well now we have to deal with that fraction. How do I get rid of a 1/6? The easiest way is to multiply by the reciprocal. 1 over 6, the reciprocal of that would be 6 over 1. So I'm going to multiply both sides of this by 6. If I multiply 6 by 1/6, it cancels and I just have x. And then 3 times 6 is 18, which is what I was asked to prove. The reason that I was able to get to this answer is the multiplication property of equality. I multiplied both sides by 6, so the reason must be the multiplication property of equality. Oh, let's try a 4-step proof. First thing to do, of course, is just write down your given. Negative 4 times the quantity 5x minus 7 is equal to 68. The reason is that it was given. So since we have these parentheses this time, the first thing I need to do is distribute. So I have negative 4 times 5x, that's negative 20x. And careful here, it is a negative times a negative, so that's a positive 28 or plus 28. The reason I was able to do that is the distributive property. Now I need to keep solving. I'm trying to prove that x equals negative 2. Well, the next thing I would need to do is subtract 28. So I have negative 20x equals 40. Since I subtracted, my reason is the subtraction property of equality. And then the last thing I need to do is get x alone. X is being multiplied by negative 20. The opposite of multiplying by negative 20 is dividing by negative 20. So divide both sides by negative 20, and I get that answer of x equals negative 2, which is what I was asked to prove. The reason is the division property of equality. I divided by negative 20. That's how I got to my answer. Which, by the way, if you get to an answer other than what your proof statement was, it means you did something wrong. Your given and your proof should always end up matching. This is the correct answer. X equals negative 2 is what you're supposed to get. So if you got, x equals positive 2 or x equals negative 5 or anything other than negative 2, you need to go look back through your work and figure out what happened. All right, let's take a look at our next one. I notice that we have like terms. But before I can get to that, I need to write down my given. 2x minus 5 plus 4x equals 7, that's my given. Now I can deal with like terms. It's actually a pretty common mistake that I see that students skip this given statement, and I get it because it kind of feels pointless, like it was already written on the page for you, so why do I have to write it again? But it is just a formality when you're writing proofs. The first thing that you write down is the given statement, and then you start solving it. So now let's take care of these like terms. 2x plus 4x gives me 6x. The reason that I'm able to combine like terms is the combine like terms reason. That's all there is to it. And now I'll solve the rest of the equation. I'm going to add 5 to both sides. The reason is the addition property of equality. And then I'll divide both sides by 6 and get to that answer of 2 that I was looking for, and that was because of the division property of equality. Alright, let's write down the given statement for our next one. 7x minus 19 equals 4x plus 11. The reason is because it was given. All of the proofs that we've looked at so far really only had one correct order for solving, but this is an example of a kind of equation that we've actually talked about quite a bit so far this year, that there's 4 different correct ways to begin. So your proof might look different than my proof, and as long as you're using the properties of equality correctly, then you're fine. But our options here, you could subtract 7x from both sides, you could add 19 to both sides, you could subtract 4x from both sides, or you could subtract 11 from both sides. All of those would be a correct way to begin. Personally, I like to start with my variables, and I like to keep them on the left-hand side, so I'm going to start by subtracting 4x from both sides. And that gives me 3x minus 19 equals 11. Since I subtracted, that means it's the subtraction property of equality. Then I'll add 19 to both sides, so 3x equals 30. And that was the addition property of equality. And the final step is to divide, so I get x equals 10. And that was, of course, the division property of equality. Alright, this is our last proof. It is 6 steps. Let's see if we can handle it. First, just copy down your given statement, and your reason is the word given. Now there's a lot going on with this, but the first thing I notice is that I have parentheses. So that means I'm going to need to use the distributive property. So for now I'm just going to copy down 17, that part doesn't change, and then I'm going to multiply negative 4 by 13, that's negative 52, and negative 4 times negative 2x, that's positive 8x, right? Because that's a negative times a negative. So be really careful when you're multiplying distributive property when it's in the middle of an equation like this. A lot of students forget the negative in front of the 4, and that becomes a minus 8x, and then you get a wrong answer. It is negative 4 that we're distributing, so just be careful with your signs. And then on the right-hand side, I just copy down 5x minus 11, because nothing changed about that yet. So what's my reason? Why was I able to do this? Your reason is the distributive property. Now, I see that I've got some like terms over here on the left side of my equation. They're both constants. They both don't have a variable, which means they can be combined. So I'm just going to do 17 minus 52. That gives me negative 35. So negative 35 plus 8x equals, again, 5x minus 11. That part hasn't changed yet. The reason I was able to do that is because of combine like terms. I am allowed to combine like terms. My reason is I combined like terms. All right, now I need to get my x's together on one side and my constants together on the other side. And this is another one of those equations that you have a few different ways that you could begin. You could add 35, you could subtract 8x, you could subtract 5x, or you could add 11. All of those would be a correct way to proceed. It's up to you. I'm going to start by subtracting 5x. So I have negative 35 plus 3x equals negative 11. Since I subtracted, my reason is the subtraction property of equality. Then I'll add this 35 over to the 11. So I get 3x equals 24. Since I'm adding, that's the addition property of equality. And then the last thing to do is divide both sides by 3, so I get that answer of x equals 8. And my reason was the division property of equality. Now, it just so happened on this proof, and I think all of the other proofs that we saw today, that we only used each property once. That's not a rule. You can use each of the properties as many times as you need to in one proof. So if you need to use the addition property twice, or the subtraction property twice, or the distributive property twice, or whatever, you can use each property as many times as you need to in each proof in order to arrive at your proof statement. And that's all you need to know about algebraic proofs. In our next lesson, we're going to prep ourselves for what we need to know in order to write geometric proofs. So we're getting to geometric proofs in 2 lessons. Our next lesson we have to explore how do we interpret and draw and analyze diagrams.